Hi everyone, I'm John Cilli. Already had an introduction, so I'll skip through that slide. But I'm from Picatinny Arsenal. So I'm going to talk about this new workflow. So first, I'm going to talk about the issues with the workflow. Why do we actually want this new workflow, and then how are we actually going to do that through historical databases, design of experiments, and Bayesian optimization. And then, so end the presentation, I'm going to talk about progress and our future work. So what we have now is just a basic design loop. So we get requirements in from the customer, we generate some data using our model through the surrogate model, we optimize the parameters, gather inputs, and then put it into kind of a trade study for our customer, and just an iterative process until we get the results or the answers that our customer was looking for. And some of the issues that we see with that is that early on within our trade space exploration, it's very large with not very confined bounds. So the number of runs that we needed to do were just very computationally expensive, taking somewhere weeks to months and stuff to run. And also with sharp physics changes, say like you go from like supersonic to subsonic, doesn't really model too well with that. So like, why do we actually want this? So we kind of saw that AI is a very growing field in this AI spring that we're in right now. So we kind of reap the benefits and kind of make some innovative designs to capture all the benefits of rapid conceptualization, and then also further inform our analysts. So this is our new sign loop. So in the top left, you see our historical database, which will inform our design of experiments, and our Bayesian optimization and machine learning loop, which then feeds our past design process and stuff and feed into it. So I'll go further into both of those things. So this is our historical database in the top left. So some ways that we can go about this is either a data lake, which is just like raw unprocessed data, or we can have a data warehouse, which is just a data lake with a pipeline to have processed data that would have more meaningful data, maybe some metadata within that. And the ability to track projects will increase. And then also we may have some SQL or NoSQL database search queries that we can enable to draw some data that we can inference from. Then also we're going to go down to our design of experiments. So there's a lot of stuff on design experiments here, so I won't go too much into it, but essentially you just explore space filling designs that will cut down the number of runs to a large magnitude, so to where we can run some of our simulations within hours instead of a week. And it will just overall increase our understanding of the trade, creating a neural network that we can use for predictive modeling. And also the Bayesian optimization component of this. So Bayesian optimization, you have a surrogate model, which you see in the top left, and then you have the acquisition function in the bottom left. They're great for black box models or expensive to compute models. So I'll go more into how this is actually working right here, but you can see the acquisition function is probing where to test next within the surrogate model, which is usually a Gaussian process, but it can be anything with a confidence interval. So, and then, yeah, acquisition function should be anything that's heuristically designed. So in this example, next, it's just the upper bound, the 95% confidence interval of our surrogate model. So as you can see, we can find the maximum point within our acquisition function right there at 0.54. And then we will probe that point within our surrogate model right there to narrow our bounds within our confidence interval. And we'll continue to probe until we are 95% confident that we have found the absolute maximum within our model. And does that be a confidence interval? You can set the number of iterations you want to run or anything else with like with confidence within it. And then also feed back into our design loop that we have right now. So we have made progress. We'll again set later, getting a little bit ahead of myself with time. But so a big thing is when we do have past runs of like DOE Bayesian optimization, we can use historical data and store that to inform future designs within DOE or Bayesian optimization to feed into our loop. Some of the tools that we've used, Python, just a high-level programming language. Jupyter Notebooks is really good just for sharing code and files and visuals. And then Dask is a distributed computing package within Python. So if you have multiple nodes or a high-performance computer, you can distribute a lot of those nodes across different processes within your runtime. And then Hall Views is just a data visualization package. So it's just a lot of interactive graphs are easy to visualize a lot of data all at once. And Scikit Optimize is where we're drawing our Bayesian optimization from. So we fit our current model to the scikit-learn framework. So we can draw a lot of search algorithms from that package from Python. So we don't have to recreate the wheel with creating our own search algorithms. We can just call on scikit-learn search functions to do that. And Scikit Optimize also has the GP minimize function, which is the Gaussian process model that can be used to create the Bayesian optimization that I talked about earlier. So what we've done so far, we've on the Bayesian optimization side, we brought that into our lab and we fit that to our model. And currently we're trying to get this onto a current project so we can kind of see how much is it worth the time actually investing it further and see above the baseline of our current process, how many benefits it actually gives us and stuff. And then with the design of experiments, we have statisticians come in and then kind of like build their DOEs on top of our current process to cut down the number of runs. And then as far as the database, we have looked into like an ontological framework for that. And then for the future, I think we want to expand that further and then also kind of get the Bayesian optimization DOE more so into a pipeline, a data pipeline. So it's like a little bit more automated than having analysts come in and from project to project have to rework the entire process over and over again. Because if you can just maybe have a GUI or something like that, you could have just a systems matters expert come in instead of like a PhD in stats or like a computer scientist to rework the entire framework again. And then, are there any questions?
We have time for questions.
Okay, cool. Yeah, no.
Thank you very much.
Yeah, no problem.
If you come see you at the poster session.
Yeah, for sure.
All right.